Next question. There are 6 boxes on a truck as shown above. Okay, so you take a box one at a time and you place it on the ground or on top of another box. Okay, so this part which says you can take the box provided that it does not have a box on top of it. So let's say we do have this thing. We do have this, right? Well, you can't take C because there are boxes E and F above it. So we can only take E. Let's say we take this and we put it here. So this is box E. And then we take F because there's no box on top of it. Maybe we put it on the floor. That's possible, right? And now we can finally take C. Maybe we put it on top of these two, something like that. So this is a possible way to do it. You can put D. And now you can just choose between E and F after. So something like that. You can take a box if it has a box on top of it. So for this one, you can actually just try to look at the choices one by one. It doesn't really take too long, right? Let's start with A. Is it possible to do A? So basically, you put E down first, right? Because it's, yeah. You basically take E and you put it down over here. That works because there's no box on top of E. Over here, right? There's no box on top of E. So you can just get it, take it, and then put it over here. Yep. And then next he put down an F. He took it from here and then we put it here. So that's possible. And then we take the C from the original and put it in the new. That's possible. Take the D from the original and put it in the new. Take the A from the original and put it in the new. And we take the B from the original and put it in the new. So A is indeed possible. Okay, let's check B now. Okay, so he put down E first before he put any of the other boxes. Okay, so let's see if that's possible. We take E from the original and put it here on the floor. That's possible. And you take F from the original and put it down on the floor. I mean on top of E in the new one. And then you took C, which is possible, and you put it over here. But then you realize that he took B. He put B on top of C. But you can't really take B over here unless you would have taken this D. Right? But he put D on top of B, which means he took B first from the original, put it over here, and then he took D. But that's not possible because you're supposed to take D first because it's on top of B. So this is not possible. So which of the following stacks could he not build? He can't build B, so B is the right answer. 13B, yes, it is indeed B. Okay. In the following calculations, the same digits are hidden under the same figures. Okay, so there's a number under all of these. Okay. So you basically just have to try then. I think this one makes sense, right? Because there's a repeating digits. That means this one could be like 11 or 22 or 33 and so on, right? But you see, right? Circle plus triangle are 1-digit numbers. That means at maximum they could be 9 plus 9. So the maximum number possible value for this 2-digit number is going to be 18. Right? So it can't be 22, it can't be 33 as we said a while ago. So this one is forced to be 11. So blue circle is covering 11. Blue square, sorry, is covering the digit 1. So this is 1, this is 1, and this is 1. All right, now we just have to try and guess some stuff. At this point, it's just guess and check. Right? So we can have like a 5 and a 6. Let's see if that works. 6 plus 6 is going to be 12, right? So this is supposed to be 2. But then over here, a red circle covers 5. And so it can't be 2 anymore. That's not possible. Maybe we try a 6 and a 5. This one is 5 plus 5. It's supposed to be 10. But a red circle is covering 6. So that's not possible. Next option is maybe 4 and 7. Let's try that. 4 and 7. 7 is 14. Does it work out? Red circle is covering 4. red circle is covering 4. Okay, so the value of this is going to be 7 times 4 times 1, which is 28. Let's see if it is indeed 28. 14D, yes, it is 28. Okay, Ada has built a tower of 8 discs as shown in the picture above. Ada removes a second disc from the bottom of the tower. Okay, so we remove this one. There's no more white disc. And then she removes the third disc from the bottom of this new tower. Okay, so you don't count this white one anymore because you removed it. So this is the new tower without the white one over here. So you remove the third disc from the bottom of the new tower. Okay, this is the first disc from the bottom, second disc from the bottom, third disc from the bottom. So the blue one is what you remove. Remove this one, do the same thing. And she says, then she removes the fourth disc from the bottom of the new tower. What is the new fourth disc? First disc from the bottom, second, third, fourth. So you remove the orange one. And then she removes the fifth disc from the bottom of the new tower. First, second, third, fourth, fifth. So you remove this one, the orange one on top. Which tower does Ada end up with? So you're looking at a tower that has, from the bottom, blue, orange, white, blue. Blue, orange, white, blue. Blue, orange, white, blue. Okay, let's see if it is indeed A. 15 is A. Yep, it is this one. Yeah, so just this one, right? You just have to be careful. Right, this is supposed to be from the new tower. You're removing from the new tower. So you can't just like, oh, say, oh, remove the third disc from the bottom. So the third disc from the bottom would be like 1, 2, 3. So you're removing orange, but no. That's if you're removing from the old tower. The new tower, this one doesn't exist anymore. So you have to count 1, 2, 3. 1, 2, 3, and remove the blue one, for example. Yeah, so just be careful. Or you could write it with pencil, like this. Nah, actually, I think this one would be faster. Yeah, just be careful. Try not to make a careless mistake. Okay, 16. John writes the numbers from 1 to 4 on a sheet. So over here, over here there's 1 to 4. Then he flips the sheet and writes the numbers 5 to 8. So you write 5 to 8 on the backs, right? So you flip it this way. So as you can imagine, if you have this paper, right? If you have this sheet of paper and you flip it, although 1 is on the left, when you flip it, it's actually going to be behind this square, right? So it's 1 over here, when you flip it, is going to be behind 7. 2 is going to be behind 6. 4 is going to be behind 5. And 3 is going to be behind 8, because you flip it. Yeah, so this is supposed to be the back of this sheet of paper. Okay. Then you cut it up and you put it in the row as shown below. Okay, so you basically have 4 cards because you cut it this way. You cut it like this, right? Okay, so some of these are white from the front. White from the front, and some of these are facing us using the black color. Right, so if we can see 5 on the white side, that means behind 5, behind it is going to be 4. So this one is hiding a 4 in the back, is a 4 in the back. Okay, so for this one, that is 6, right? When we flip the 6 card, it's supposed to have a 2 in the back. So this one is hiding a 2 in the back. Okay, so we basically use this one and this one, right? So that means these cards are either 1, 3 or 3, 1. All right. So what are some of the numbers represented by the question marks? So these question marks are supposed to be 1 and 3, or 3 and 1. So the sum is just going to be 4. Let's check if that's right. 16A. Yep, it is A. Okay, 17. Mark had 5 boxes of chocolate labeled A, B, C, D, and E. The chocolates in the boxes have been given numbers according to their flavor. Okay, so basically in like this chocolate box, in this box, right? Box labeled A. You have chocolates 1, 2, 3, 4, 5. Okay, so you basically ate a bunch of these. Let's say like he ate this, so 5 is what remains. And he ate this, 6 is what remains. Something that looks like that. Basically, this is what you end up with over here. So in this box, only the chocolate type 5 remains. In this box, only the chocolate type 4 remains, and so on. Okay, if you take a good look at it, right? This box, after he ate like 4 chocolates, it still has a chocolate type 1 in it. And if you realize, right, the only box that could have come from is this box, box A. Because boxes B, C, D, and E, they don't have a chocolate type 1. So this one is supposed to be A. There's no way. It has to be A for sure, because this is the only box that has a chocolate type 1. Okay, so if this is A, right, we can't use this anymore, because this is basically A now. Yeah. Okay, this box has a chocolate type 2. And as you can see, only 2 boxes have chocolate type 2, A and B, right? These 3 boxes don't have a chocolate type 2. But as you can see, we already used, this is already A, so this one has to be B, right? Because it can only be A or B, but this is A, so this has to be B. The same thing, so this is A and B, same thing. Chocolate type 3 can only be in box A. Let me use pink. Boxes A, B, and C. D and E don't have 3, so it can only either be A, B, or C. But as you can see, we already used A and B over here, so it can only be C. Yep, and so on, right? Okay, this is gone now. So D has a chocolate type 4, and a chocolate type 4 can only be D. So this is D. And then lastly, by process of elimination, because these are A, B, C, and D, this one basically just has to be box E, which is E. Okay, 17. Is 17 E? Okay, yes it is. Okay, good.